Hello, student. Precalculus, Chapter 2, Section 4. Complex numbers. Also, we're going to talk about imaginary numbers. In the past, we said square root of -9 not available because we cannot take square root of negative numbers. However, we're going to define an imaginary number to deal with this scenario. So this one going to be written this way: square root of 9 multiplied by square root of -1. That's the same thing. Now define I equals square root of -1. So this is imaginary. It's just we are imagining I equal this. Okay, so the I is the imaginary number. So this one will be written this way. We know the square root of 9 is 3, and this one I. That's it. So anytime you have square root of -9 or a negative number, you do it this way: negative square root of -81. That's equal 9i. Automatic. You change a negative to be an I and do standard square root. Interesting enough, if I say, this is really, we're gonna do this a lot, I square is equal square root of -1, everything square. Well, square will cancel the square root, that's equal -1. Extremely important. I square equal -1. What is complex number then? This is for all the thing we're talking about imaginary. Complex number are two part: A plus BI. Real plus imaginary. Okay, that's the complex number. So basically, complex combination of real and imaginary number. That's a small example they have here. They have -5 plus square root of -9. We say automatically we convert this one to an I. So this becomes -5 plus, it's not negative, a plus 3i. Okay, because the negative here become an I. Immediately convert the negative to an I. That's the answer. That's it. So we have the real part is -5, the imaginary part is the 3i. Well, we have kind of hypothesis here that if I have two complex numbers, a plus bi equals c plus di, the only way these can be equal if a equals c, that's a condition, and b equal d. So that's the only way they can be equal. Real equal real, imaginary equal imaginary. Operation with complex numbers. That means we're going to add them, subtract them, multiply them, and divide them. So let's take an example. If I have two imaginary or two complex numbers, I'm going to call it A. Let's say here -3 plus 2i. B equal -4 3i. We're going to do the following. A plus B. A minus B. We did this before with standard numbers, very similar. Then we're going to say A times B equal. Then we're going to do A divided by B equal. Then we're going to say A divided, oh, let's do it here. A divided by B minus square root of 16. Okay, let's start. When we add, it's easy, just put them next to each other. -3 plus 2i plus 4 minus 3i. Now combine the real with the real. That's equal -3 plus 4. Then imaginary with imaginary plus 2i minus 3i. Okay, that will give you -1, also -i, because -3 and 2 is negative. That's it. That's the addition. In subtraction, remember, guys, you must put parentheses. -3 plus 2i minus open parentheses 4 minus 3i. That's equal. Let's do, we have to distribute the negative first. -3 plus 2i minus 4 positive 3i. Here is the deal. This has become positive. It's not negative anymore. It was negative multiplied by negative is positive. Now we can combine real and real, -3 and -4. Let's do it in our head, -7. Now 2i plus 3i, that's 5i. You see what I see? In subtraction, the whole is completely different from adding. Okay. Now multiplication. Multiplication, we put both of them in parentheses. A, oh, not A, -3 plus 2i, this is the A, multiplied by the B, which is a 4 minus 3i. Here in multiplication, we can multiply real and imaginary. And imaginary times imaginary. We can do that, no problem. So multiplication doesn't matter. Okay, remember that. Multiplication is okay. So we're going to say -3 times 4. That will give us -12. Now, -3 times -3 of I is going to be plus 9i. See that? Now we have negative 3 times 4 is negative 12. Negative 3 times negative 3i is positive 9i. Next, we do 2i multiplied by 4. That's plus 8i. Now, multiply by negative 3i. So we're going to get 2 times negative 3, that's negative 6. Now we have I times I, that's I squared. Okay. Do you remember what does I square mean? Oh, the value of it? Let's write it down here as a reminder. I squared is equal negative 1. So that's what we're going to do. We're going to say here negative, I can make it fit in here. Negative 12. We have 9 plus 8 because this is I and I. That becomes 17i. Now this one, negative 6 multiplied by negative 1 because we converted to I to negative 1. Now let's do this again. Negative 12 plus 17i. Negative give you positive 6. This is I. Now this is real number. And so negative 12 and 6, that's negative 6 plus 17. I always put the real first. That's your final answer of multiplication. It looks a little bit hard, but not that hard. Okay. With dividing, I cannot do it right now. We have to learn something different. We'll be back, okay? There's more example in the book. I suppose I put it in one place would be easier. As the same things. Complex conjugate. That's what we need the conjugate to do the dividing. We cannot do dividing without understanding the conjugate. It is simple. If I have a complex number, a plus bi, that's it, that's simple. So conjugate of a plus bi equal a minus bi. That's it, the inverse. So kind of just change the sign to be, flip the sign, positive to negative. That's a conjugate. Now, if I have a minus bi, conjugate of a minus bi, you guessed it, is just flips the sign in the middle, a plus bi. So all what we do, flip the sign in the middle, and we get the conjugate. What would happen if we multiply the number by its own conjugate? If I say a plus bi multiplied by the conjugate, which is a minus bi. We'll do it the same way we did before. We distribute a times a square. A times bi is negative a bi. Then we go to the bi. Bi times a is positive abi. Now, multiply bi by bi, you get negative bi square. Now we know I square equal negative 1. Let's continue here. a square. We have negative abi. Because this is positive and this is negative, what's happened, those they come up to be the same and they cancel out in addition. The only thing is left, negative b. Oh, this is square here because b times b is b squared. And we have here b squared multiplied by negative 1. So at the end, this is equal a square plus b square. It is a real answer. It's better to remember this because you don't need to do this every time. So this becomes a formula, a plus bi multiply a minus bi. This is a formula. You need to remember it. Write it down in the formula sheet, or maybe it's already there. Okay, now we know about the conjugate. We know what happened if we multiply then the complex by its own conjugate. Give me a squared plus b squared. How are we going to use it in that problem in dividing? Okay. What we're going to do, we're going to divide. We just put them on top of each other first. Plus 2i divided by 4 negative 3i. What we're going to do, multiply top and bottom by conjugate of bottom. So what's going to happen here? Let's do that. So negative 3 plus 2i over 4 minus 3i. What's the conjugate of the bottom? 4 plus 3i over 4 plus 3i. You can see here it's like done nothing. This is equal 1. But why did I do that? Because I can multiply top and top, bottom and bottom. Okay, so this basically equal you have negative 3 plus 2i multiplied by 4 plus 2i, 3i, over 4 minus 3i multiplied by 4 plus 3i. Remember what's happening? Because this is a conjugate multiplied by the original 4 minus 3i, the original one. So the answer immediately a squared plus, guys, not negative, plus 3 squared. What happened to this negative? It cancel out if we do regular distribution. But if you remember the formula, you don't worry about it. This is always is going to be 4 squared plus 3 squared. On top, we're going to say negative 3 times 4 is negative 12. Negative 3 times 3, you get negative 9i. Then 2i multiplied by 4, we get plus 8i. Then 2i multiplied by 3i, we get positive 6i squared. Okay, positive 6i squared. Let's keep going. Negative 12, 8i and negative 9i, we get negative 1i. Now we have a plus 6, negative 1, because I squared is negative 1. And the bottom we have 16 plus 9 So this equal what? -6 and -12, that's -18. 16 plus 9 is 25. I'm gonna split it. I don't know the sign yet. This is a 25, and I put the I here. What is the top? How many i's do I have? I have only negative I. -1/25i. That's your final answer. The real part is -18/25. The imaginary part, 1/25. you, you need to have your answer like that. Now, the last question said a over b minus 6 square root of 16, -16. Well, what I'm going to do, this is already did it. So normally you do those two complex numbers first, then you add your -16 is 4i. So basically this is equal a over b minus, because this minus from outside, from inside become 4i. Now let's combine those together. This is the a over b. So this thing is equal -18/25 minus 1/25 I minus 4i. Now, how do I add -4i with 1/25? I need to have the same bottom to be added up. You can use decimals, or if I multiply top and bottom by 25, is this become 100/25. So this equal -18/25 minus 1/25. Well, let's do it this way. I put it on top here, minus 100i/25. So my final answer, -18/25 minus, because 101 become a 101 i/25. That's it, guys. Okay, let's see what's next. This is an example in the book about dividing and using the conjugate. Now, complex solution for quadratic equation. Solve this problem. This problem, we cannot factor it out. We're going to use a formula x equal -b positive negative square root of b square minus 4ac over 2a. Remember here, what is a? A equal 3, b equal -2, c equal 5. Let's plug in. -b, so negative, well, let's put this, -b, positive negative square root of -2 square minus 4 multiplied by a, which is a 3, multiplied by c, which is 5, over 2 multiplied by a, which is 3. Okay. All right, let's say equal here. See how I maintain the equal sign all the time? Negative, negative is +2. I can split it from here, you know. Let's see here. I'm going to split it here. 2 times 3 is 6. Positive, negative. 6 square root of what? 4. 4 times 5 is 20. 20 times 3, that's -60. Okay. This has become 1/3. Positive, negative. 6 square root of -56 equal 1/3 positive negative 6 square root of 56i. You know, all what we do, convert this negative to be I. That's it. That's your solution. We have two answers. 1/3 plus this and 1/3 minus this. What is the square root of 56? You can use your calculator, so you can convert everything to decimal at this point, or you can leave it like that. Okay, so some quadratic equation can be solved and get imaginary numbers. I think this is the end of section 4 is completed. And that's what I'm gonna cover from chapter 4, only 4 sections. Next time we'll go to chapter 3. Let's see if there's any practice available, so you can do that immediately after you listen to the lectures. That's the best way to do it. So we are in section 4, chapter 2. Well, that's the same example I solved for that section. You have A and B, and you have to subtract them. I'm not asking for adding because it's easy. A minus B, you could do the adding. A minus B, A times B, A divided by B, then A divided by B, square root of 16. Then solve the quadratic equation same way. All right, we'll stop here.